Welcome everybody to your honors class for BMEN 207, Computing for Biomedical Engineers. We're going to go over a few differences between what you'll be doing in the honors class and the BMEN 207, the regular class. So let's get started. So the organization, all of your assignments are going to be organized with the standard class. You'll do all of the things that they do, plus an extra few assignments, as well as a project that we'll describe. So really kind of the things to understand that what's different and what's extra is that you'll have a project that's due November 30th, and then project proposal that's due on September 30th. So I'd like to have a personal conversation with you during my working hours, or you can even do it by email if you wish, to describe what your project is, and then there'll be a 3-page or less proposal will be due on September 30th. And then your final project will be due November 30th. So let's talk a little bit about the details here. Is that you can do this project as a team or an individual. And then for your proposal, I'd like to see these elements: for problem statement, application background, the technology you'll be using. I put support vector machine, which is a machine learning technique, as an example there, the expected outcome, and then an overview of the data. If you're doing machine learning or web services, a couple examples I'm going to show you. Which database did you use? What's the description of the data? How was it labeled, and so forth? And then a flow chart of your project, and then what were the roles of each of the team members. So I don't want a huge report here. I'd like very concise, 3 pages or less is fine to overview each of these topics. Some possible projects. So I really think a popular subject today is machine learning, and there's a really good abstracted module in Python called scikit-learn. There's other modules such as PyTorch that you could use as well. There's a lot of different techniques here, and what's interesting, over the last 5 years, these things have been abstracted to the point where it's very straightforward to use. Also, there are databases that are a part of scikit-learn that you can use to quickly get up to speed. There's one for handwriting, for example, that recognizes different images of handwriting, different letters, and then shows you how to create a model for doing machine learning. During our regular class, we will look at images of melanoma versus mole and come up with a method to be able to process the images so that we can make a prediction of melanoma or mole. This doesn't use machine learning. It uses a different image processing technique to be able to predict. But you could apply the machine learning techniques I've listed above, or one of them, on the database that we have, for example. There is a part of scikit-learn of breast cancer detection. It's not images. It's basically information about the tumor size and several different features that are labeled within within a database, a text database. I think that there's a lot of opportunities out there to do image classification. When I say binary classification, is it a member of a group or not a group? And then I'm particularly interested in infrared images and how they can be used in biomedical applications. So if you have an idea there, the challenge with all of these is the data sets. If you have an idea for a project, I will see if I can help you find a data set, but that may be the limitation. For a true neural network, deep learning, you probably want to have more than 200 images, but some of these other techniques can be useful for and predictive with smaller sets of data, but not as accurate. So maybe 50 to 100 images would be fine. So that's going to be one of the challenges, is how to get your hands on a data set. In addition, I will consider non-biomedical applications. This is a learning exercise, and I think going through the learning exercise, you will come, if you learn machine learning, you will then come to understanding of the basics, and then can use that in the future for biomedical applications. I have a tendency to just want to focus on biomedical applications, but if you come up with something interesting, I'll consider it. So here's some further reading. This is the scikit-learn webpage. It's an introduction to machine learning. It's got tutorials. It has different data sets that you can look at. And I encourage you to go through some of the tutorials so that you understand the basics, and if this is going to be something that interests you and that you want to build a project around it. Also, here is a review paper that talks about machine learning being used in biomedical engineering applications. I think it has 7 or 8 papers that it discusses, and this will give you an idea of the type of applications that are being performed in the biomedical area. Okay, so here's another set of project ideas. I think that there's a lot of opportunities around web services, and if you don't know what a web services is, that's okay. It's pretty straightforward in that there's an existing database that's out there on a server, and then you have an application in Python and you request data from that database. For example, if you were doing a nutrition application and you wanted to understand what the calories were for a Whataburger, that is in a database somewhere. We go fetch the data and then present that to the user. Actually, we will do a web services example. September 5th is one of your assignments, and it uses a very powerful nutrition database, and actually has a fitness exercise fitness. So you can basically type in I swam 5 minutes and ran 20 minutes at a 10-minute pace per mile, and it'll return back the number of calories burned, for example. So I think that there's a lot of interesting opportunities in this space for doing web services, and this is really how the world is working today. You can tap into data at Twitter and Facebook and Fitbit and other places to be able to get anonymized data for health. And finally, other project ideas are welcome. If you have project ideas that are outside of machine learning or web services, I'm happy to discuss those. So for your reading or viewing for web services, I really like Corey Schaefer's videos online. They're follow-along videos similar to what I've done for the class, and you can get a very quick understanding of what web services is by Corey Schaefer's request video and then request HTML web scraper. So the web scraper basically, and an application for the web scraper is actually Hopkins COVID-19 or coronavirus website, and that they tap into, I think it's more than 4,000 different databases or websites, and then they collect data from those websites called web scraping, and then organize that data to track the progress and infections for COVID-19. So that gives you some ideas on 2 of the really hot topics out there for computing, which is machine learning. And I'd like to primarily focus on supervised learning, which the Scikit-Learn Toolbox module has a lot of techniques for that, as well as existing data that you could access through web services. And then finally, here's a directory over nearly 1,000 different web services that you can tap into. Once again, September 5th, we'll have an assignment that shows you how to use web services. And finally, grading for your honors class is going to be slightly different than BMEN 207. Your assignments will be 15%, and then the project 1, 2, and 3 will be 15%. The regular class doesn't have the project 3, and everything is 20%, and that's in the syllabus. So your next action items is you can do this as an individual, or you can organize a team, set up a meeting, or attend office hours to discuss the project with me before you turn in your proposal, and then locate a data set or source, and then the 3-page or less proposal for the project by September 30th. So if you have questions, please send me an email or attend one of the office hours, which is during the class period for your class. So I've made it very, very convenient so that you have that time set aside so that you can talk to me or a TA and help you through this course. All right, I look forward to meeting each of you. Bye.